Excellent. Okay. Press the record button. Would like to take this opportunity to say thank you for joining us today. Today, we're going to be hosting our webinar titled Getting Started with Eagle. We host this the second Tuesday of every month. We like to do this cadence because we're continuously getting more and more people joining the Eagle community consistently, as well as if we go live, we just feel that we're able to address questions live and take care of them. So that's why I like to host these every month. So we're going to go ahead and begin. Today, we are lucky that Jorge Garcia is joining us today. Jorge, want to tell us a little bit about you?
Hey everyone, so as you guys probably know if you've been here before, I've been working with Eagle for the last 10 years or so, and I'm on the forum, so if you're ever there, feel free to say hi. And we look forward to hopefully you guys getting the most out of this webinar and being able to get your questions answered.
Thank you, Georgia. I've been with Autodesk Eagle. I mean, I've been with Eagle quite a long time as well. I've been working with Jorge for a while, and we really enjoy doing these webinars on a monthly basis. And make sure that you're looking at your control panel to see the different series that I've been scheduling. Okay, so just want to do a brief introduction before we actually go live with Eagle. So a rough description of Eagle is that it's a platform that consists of multiple workspaces. The primary workspaces consists of the schematic editor, the circuit board editor, and our PCB library editor. Each one work in conjunction and depend of each other. That way you could get your design finally created. At first, we're going to take a good look at the Eagle control panel. This is basically where you manage everything, where you could see all the aspects of your design. Then we're going to actually go into the schematic editor. I'm going to go ahead and build our brand new schematic, define a frame for our workspace. That way we have, it's actually, it fits in an area and it's easier to read a schematic that way. We're going to place our components. We're going to learn how to rotate them, mirror them, how to move them in a group, create our connections. And from that point, we'll go ahead and create a circuit board. Now the circuit board, we're not going to lay it out. We're going to do that in 2 days. So we're going to, on Thursday, is join, if you don't mind, come back, and then we're going to actually be working on the board. Okay. So let's go ahead and go live with Eagle. This is the control panel. And today I actually wanted to highlight a particular area because on 9.5, which was recently released, it's a little bit confusing at times to 100% understand this whole, the way this library is now structured in its folders. But it's actually pretty simple. As you could see, if I expand the library tree, this is the control panel, and I'm on the home tab. That way you could see the webinars that are up and coming, our tips, and our latest videos that we have hosted. Okay, now you notice that it's divided in 3 sections. Okay, so here is the libraries that I have managed, and it has my name on it. These are my managed libraries. Now, these libraries that you see here are managed libraries that are either shared with me or that I have access to. For example, where it says Eagle PCB, this is the Eagle library. This is the one that's being made by the Eagle librarian team. Okay. And this is where their libraries actually reside. So if I expand this, you're going to see all the libraries that actually come by default with Eagle. Okay. This is another library that somebody actually shared with me as well. And this is actually, it has actually a lot of good parts, and you'll see it on the managed library. And these are just different projects and persons that I work with. Now, the Limo Fried and the Spark Fund, these are libraries that are available, that are managed, that you have access to them through the managed library system. And I'm going to show you how to get to that in a few minutes, how to get to these additional libraries if you don't have them by default, because by default, they will not install. we expand design blocks, you could see the design blocks that we currently have available that you could use and add to your design if necessary. These are kind of like sub-circuits that you could add to your existing design. Different design rules, the DRU files. We have a lot of them that have been contributed by different board houses. User language program is a system by which is a C-like language that allows you to expand the capabilities of Eagle by creating your own commands if you wanted to. And script files are like DOS batch files. If you want a sequence of commands to run in Eagle, you will actually create a script file. The CAM job has all the different CAM jobs that are available to export your files to create your files that are going to be necessary to have your boards actually created. So these are our different ones, and we have some made by third parties that are actually pretty nice. So if you're going to be working directly with a particular board house, we have a really nice set of CAN files actually available as well. And SPICE models, these are just models by which you could actually assign models to your components if you're going to actually use a simulation. And I'm going to be doing a brief demo of that, very brief, okay? So now let's go ahead and start with the design. As you can see, we have the projects folder here located. I'm going to go ahead and expand it. And I'm going to go here and I'm going to just do a right click and I'm going to select the option new project. Okay. As you can see, it automatically created the project right here. I'm going to name this. I'm going to call it webinar 2019. Now you may ask, where's this file going to be located? What folder is this located? These folders are actually located in your home folder. So let me go here, options, and we go to directories. And you'll see right here where projects, where it's defined. The default folder is going to be going to your home, documents, Eagle, projects folder. I have a finder here opened up. That way you can see what that looks like. So here's that project that I just created is going to this folder, which you could actually see my path right here. So it's going to my documents, Eagle projects folder, as you could see. If I was to double click my projects folder, that folder that I just created called webinar 2019, which is here, got created right here. Okay, and if I expand it, it only creates what we call the Eagle EPF file, which is the Eagle project file. That just keeps track of your settings as you work on this project. That's all that is. So I just want to let you know exactly where it's located, okay? Now that we've created the project and you see that it's selected, you see this green dot right here, that means that project is actually selected. I have to go back to the libraries just for a second to show you one more thing that I forgot to tell you about. Next to the name of each library, you have this dot right here. You see right now, they're currently gray. I currently have almost all the libraries grayed out because I don't want to use them. There's only some libraries that I want to use. But if I want to change their status to use, I click on this dot here. What does this mean? This means that when I'm working on a schematic, if I'm working on a board, this library will now be available to me. If it's gray, that doesn't mean I've deleted the library. It just means it won't be available to me. That's all it means, okay? So, and I like doing this if you know what you're going to be working with, it's kind of it's kind of a time saver, but if you're not really sure exactly all the components that you're going to be using, and then it's best to have them all turned on. It's just fine. It's just for the demonstration. I like only using the ones that I'm going to need. That way it doesn't look so cluttered. Let's go back to our open fold or to our open project that we have, our active project, which you see the green dot right there. I'm going to go ahead and right click it and select new and select option schematic. This will automatically open up the Eagle schematic workspace. On the top, we have our action toolbar, we have our parameter toolbar, and we have our command line. And then on the left-hand side, we actually have a set of icons, and they're grouped based on functionalities. So they actually are grouped by based on functionalities, as you can see here. Now, this blinking cursor that you see here is the command line. I could either use the icon or I could use the command line. For example, if you're going to be adding components to a schematic, you actually use the add command. If I click on the add icon right here, you'll notice that the library is going to actually open up, as you could see here. These are the libraries that I actually have made myself available to me for this design. As you know, there's many more. I use the icon for this. Let's say, for example, I wanted to use it from the command line. I could actually just type the command add, and the same command is executed. So as you progress with Eagle, instead of looking, you may want to consider, instead of having to look for the icon, just type the command if you want to. The command line has a lot of functionalities in Eagle. So I really advise people to really consider using it. Now, remember, I was telling you these are the libraries I currently have available to me for this design. But I have a link here that says Open Library Manager. If I click on Open Library Manager, since there's no design, there's no components of the design, this section is going to be totally blank. These are the libraries I currently have in use. I select this tab. And if I click on Available, these are all the libraries that are available, including online. Not only the libraries that are mine, but including more libraries that have been contributed by our librarians and other distributors that we have allowed them to have access to our library manager system. So I could go ahead and select any of these libraries. Now, go ahead. These are done by our librarian. We have here some by SparkFun. I could click on that and select use if I wanted to use those, as you could see. And once I put it in use, I'll just use this one as an example. If I click on use, you'll see it disappears and it now becomes available on SparkFun here, in my in use tab. There's many more libraries that we actually have. And here's the Adafruit one. Now, if you ever are browsing your libraries and you see a little symbol that looks something like this, if you see any library that has a symbol like this, what this means is that that library actually has updates. Okay. In other words, that library, either components have been modified, deleted, fixed, or added to that library. So you could go ahead and click it and select update. That will actually update the library. Usually just takes a couple of seconds and it's already updated. The librarian team is constantly updating our library. So I advise to be checking on that every now and then. I'm going to X my way out of here. That way we can start working on our schematic. Okay. Now that we're here, first thing I'm going to use is I'm going to place a frame for my schematic. That way I constrain my work area. So I'm going to select the frames library. And I actually like using this frame AL library right here. Click OK. You see that the frame is now attached to my mouse cursor. I'm going to use the mouse, even though I'm on a Mac, I actually like using a PC-based mouse because of the wheel. I'm going to use the wheel, that way I could zoom out a little bit. This continues to be attached to my mouse cursor. I'm going to put it, this crosshair you see on the bottom left corner, that's the origin of the page. We always advise people to actually use that as your reference. You should always put the bottom left corner of your frame right there. As you can see it right there. Now, I don't need another frame. Therefore, I'm just going to hit the escape key and get the other parts that are going to be required for this design. I'm going to be using the 555 timer for this. Right, you see here, I have a search option. I'm going to go ahead and type in 555 and hit enter, because that's the part I'm looking for. I get no results because in the search criteria that Eagle is actually using is trying to match those 3 characters only to something that only has those 3 characters. Therefore, I could use wildcards to expand my search capabilities. So let's say I put a asterisk in the front. That means it doesn't matter how many characters it has in front. And then I could put a question mark on the other end, meaning that it should only have 1 character at the end. Now I'll go ahead and press enter to to create my, to have my search run again. And it found one in the linear library. And here we go. And I'm going to go ahead, and as you can see, here are my parts. I'll use this one through hole. I'm going to use a through hole one because there's something else that I want to demo later on when we get back together on Thursday for the library demo, for the board layout demo. I'm going to use the right mouse click to rotate my component. So I'm using right mouse. I'm going to click it twice because for every click, it rotates 90 degrees. Now I'm going to press the middle mouse button is because I actually want to mirror the component. That's the orientation I want to have this component. As you could see, you'll notice that the text that said value, which initially was on the right-hand side, now comes up on the left-hand side. I'm going to do a left click to go ahead and place this component. Automatically, I get another one attached to my mouse cursor, which I will not be needing. So I'm going to go ahead and escape and get the other components that I would actually like to use. Since I do not need the 555s any longer, I'll just X out of the search results. That way I get all the libraries that I currently have in use. A very useful library that you're going to be seeing is called the RCL library. You're going to find capacitors, inductors, and resistors. In this case, I'm going to be using 4 resistors that I'm going to be requiring for this design. So as you can see, they're categorized. And there's actually a subcategory between US and EU. Yes, because the symbolism that is used in the US is slightly different than the one used in the Europe. Doesn't mean it's any different, or it's just the way they look, okay? So I'm going to go ahead and expand here the RUS. Now, an interesting thing that you're going to be seeing here is, I wanted to show this, is this popularity column here. So designs that are actually available in public on Git, these are eco designs that are available on Git and made public. It actually keeps track of the components that are being used, and it gives you a popularity score, as you could see here. I'll go here and I'll use the 0603, very common resistor. And I need 4 of these, and I'll more or less place them something like this. Kind of guessing here. I need 2 more over here. Okay, I'm going to go ahead and hit escape because that way I can grab the other parts that I need. Now I'm going to go ahead and select my LEDs. The LED has many subfolders as well. So I'm going to expand the LED. There's the LED library, and here's the 5mm. As you could see, is one of the most popular ones. Has full bars on the popularity score. Okay. I need 2 of these. I'm using the left mouse click to go ahead and place, to rotate it. I'll place 2 of them. Let me go get a battery now. I'm going to be using, I've configured this one to work with a 9-volt battery. So all the values I'm going to be assigning to the components will work with the 9-volt battery. I'll expand the battery folder. I'm sorry, the battery library. I'm going to use a 9-volt battery, which is this one, the 9-volt battery clip. Rotate it a couple times because I want ground to be on the bottom. It's very common in schematic designs that the orientation defines positive, unless it's a sinusoidal or wave, but usually you put positive on the top and you put negative on the bottom. Go ahead and grab some capacitors that I'm going to be needing for the design as well. Go back to the RCO library. For our friends on YouTube, if you have any questions, I'll try to get to them as soon as I can, okay? So here, I need 2 of these. I'll put one here that I'm going to be needing one around here. I'm going to be needing one down here as well. Okay. And that covers all the components that I'll actually be needing for this design. Okay, I could hit the escape key and it will go back to the library. I'm trying to get rid of this menu that's up here on the top of my screen. That way I could see it. I could hit escape and it'll go back, or I could just click here on stop to finish what I'm doing so far. Okay, I don't want to hit escape because I don't want to go back to to the menu, to the library add command. So now what I'm going to start doing is I'm going to define connections. And when you define connections, of course, it's totally logic that you're going to think of line, right? Is that right, Jorge? Everybody, if you think you need a connection on schematic, you're going to be using the line command. That makes
Well,
total sense.
it used to be worse because it used to be called wire. At least now with line, I found that more people have not made that mistake. But when it used to
Okay.
be called wire, it happened all the time.
Yeah. So you definitely want to use the line command and not
No,
wire.
no, not line, not line. Net.
Oh,
You
you want to use the net command. I'm sorry. You want to use
net.
the net command. Sorry. You want to use the net command to define your connections. So you're not going to be using wire. You're not going to be using line. You're going to be using the net command. Okay. So the net command is right here. This icon that you see right here. Here's a net command. So click on the net command, or you could click on the net command, or you could just go ahead and type it. So let's start making some connections here. I'll make these right here now. There's something I want to show you really quick. As soon as I get close to a connecting point on the schematic, on the component, you notice that a bubble shows up. Okay, that means that that's the connecting point. So I could click here, and I could go to the next connecting point, and it will automatically release. Single click. Now, from the Eagle Bible, verse 1, chapter 1, you have to stay on grid 0.1 inches or the equivalent. Never, ever change your grid on the schematic when it comes to placing components or defining connections. Is there anything you're going to get out of this webinar? Please get, I can't stress this enough, Jorge.
Yeah, don't change the grid. If you prefer metric units, change the units to millimeters. It'll become 2.54. But don't change that value. Reason being, all of Eagle's libraries are built to that grid spacing. If you deviate from it, you're going to find it difficult to get everything to connect properly on your schematic. We now have snaps on the pin ends, so that helps a lot. But if you're connecting from one net to another, you don't have the benefit of the snap, so you could still run into trouble. So as I mentioned, if you're only going to take one rule away from this, please don't change the grid on the schematic editor or on the symbol editor. In the board or in the footprint editor, you can do whatever you want. But in the symbol and schematic editors, do not deviate from 0.1 inch spacing.
Thank you, Jorge. That's, yes. And there's been instances that you change the grid and then things look like they connect, but they don't actually connect it. And when you go to the board layout, you don't see your air wires, you don't see your connections, and it's because grids were changed. So stay on the 0.1 inch grid all the time. Now, if you're kind of new to Eagle, I always you may want to consider using the layer settings option and turn on the pins layer right here. That pins layer 93, you could turn it on. And you'll see these bubbles show up as well on each pin. That lets you identify the connecting point easier as well. We by default, we do not have it on because it just adds way too much information to the schematic. It clutters it up a little bit. So we usually have that layer turned off. Okay, so let's go ahead and continue defining our connections here really quick. Just using the net command, defining the connections. I'm going. I did a mistake. I made this connection to the wrong net. Here, I'll delete that discharge. It doesn't go there. Click on net. Now, here you go. Now I did it right to the output. When you do an intersection between two nets, junction points automatically will show up. So every time I do a net from one net to and stop at a different net, you always get this that junction point. This lets you know that the signal name on both lines that are drawn actually have the same name. That's what that means. That's why that junction point is kind of important. I'll go ahead and continue drawing the rest of my connections. My threshold. Okay, trying to do this as fast as I can. This goes to ground. Oops, sorry. Take that away, hit undo. This one goes there. I'll do that in a minute, okay? This connection in a minute. Okay, very well. Now let's go ahead and connect our power. The way I'm gonna handle power is, as you can see here, this is a 9-volt battery. So I'm gonna use the add command, and I'm gonna use the supply library. The supply library consists of a list of representations of power that are gonna be supplying the power for our design. But they're only representations. In other words, they have actually no contribution to the board layout. Yes, the connectivity within the schematic in itself. So I'm gonna go ahead and expand my supply library, and I'm gonna select my 9-volt battery here. Now remember, this is actually doing no contribution at all to the schematic, to the board. It's only distributing power throughout my design. So there's my 9 volts there. There's my 9-volt battery here. Okay. 9 volts there. Select yes, because I am running 9 volts right there as well. Now I'm gonna go ahead and select my ground, what I'm gonna be using as my ground symbol. And I'm gonna use the supply 1 library to select my ground symbol from here. As you can see right there. I'll go ahead and put my ground here. It connects my ground. As you could see, I do not have to run a net every time. If I line up the symbols with one pin to the other pin, I actually get that connection properly done as well. Okay. And I'll put my ground right here. And I'm going to run my net for my ground. That way I could turn on my component. And my control voltage, I'm going to put it to ground here because it's just, it could almost be disregarded. Now that I've distributed my power throughout my design, oh, I'm missing only one here, one net. This one goes, sorry about that. Okay, there we go. Now that completes our schematic. All of the connections have been defined. Let me go ahead and save what we've done so far. Okay, now the next thing you want to go back to do is actually give values to your components. I'm going to select here on these icons that you see on the right hand side. I'm going to do a select here, and right here I'm going to these resistors. This one actually has 1K ohm. This one is going to have 100K ohm. This capacitor carries 1 nanofarad. This one is extremely negligible. So this actually has 10 nanofarads. Here I'm going to be, for the 9-volt battery, I ran this on Tinkercad. I was actually using Tinkercad to test this out. And to get a visible flashing, kind of like what you saw on my PowerPoint, that little flashing, kind of figured out that if I put these at 330 ohms, I was able to get a really nice kind of a nice timing for the LEDs, and it was visible. Everything else, it was either too slow or they were going so fast you could barely even see them. So I thought that value worked out really well. And the only thing I miss here, right here, Jorge, you didn't tell me about this, the voltage. I totally forgot to turn on the 555 timer. I'm missing a battery. The connector here. And the way I'm going to do this is pretty easy. I don't want to go through the whole library to find it. I'm going to click here where it says copy, and I'm going to select one of the 9-volt battery pins that I already have right here. I'll just copy it and I'll put it here. And I'll just use a net command and run a net directly to it. And that takes care of that. So just to do a brief summary, we actually place a frame, place the components, and define the connections. Now I'm going to go ahead and finish the frame in itself. As you could see, the title adopted automatically the name of the file, which is webinar 2019. It automatically does it. Everything else has to be done manually. So yes, I'll use an example here. I'll click on the text command and I'll type in the text. Shift enter. Now, when I click OK, if it comes up in green, as you could see there, I'm going to go ahead and select a different active layer because I don't want it on the net layer. You need to put anything that has to do with graphical contributions to your design is going to go on layer 94, which is a symbol layer. As you can see, and then here I could go ahead and I'm going to leave it a proportional font. And the reason we want to keep here on the schematic on proportional font is that if you export this in PDF, it will be searchable. Okay, so the PDF file will be searchable. So we want to keep proportional. Size controls the size of the text. So I could click here and change the size of the text. As you can see there, control the size of the text. Let me make it a little bit smaller. That way it fits there. In addition to the size of the text, this ratio controls the boldness. I'm going to use a very large value. That way you could just see the difference. Okay, I guess because it's a proportional font, it's not seeing the difference on the boldness itself. Let's see if I could type in the value. Oh, it's out of range. So the top range is 31. Okay, so when it comes to boldness, that's the biggest that allows me to do it. And I can go ahead and place it right there. Okay. And Jorge, this kind of ends the demonstration I wanted to do today. I was trying to keep it within the time frame. I know I'm 5 minutes over, but in essence, I just wanted you to put your frame down, be able to make your connections, learn how to distribute your power throughout. And Eagle, in addition of using supply pins to distribute your power, if the nets have the same name, even though they're not physically connected on the drawing, we just want to let you know that if I have 2 nets and each net is called MISO, and both nets are called MISO, they're going to actually end up connected when you go over to the schematic. So nets with the same name will be connected always.
And you're missing a ground connection on the battery.
Oh.
Thanks, John. John
Hey,
saw it.
Hey, John caught me on that one, huh? Thank you, John. Appreciate that, as always. Okay, sorry about that. So I just click on the copy command and go ahead and did that. I make that. Now, you know, Jorge did the work yesterday to actually make this design with these exact same values and put it in a simulation schematic as well with the models map. So I just want to go ahead and demonstrate that really quick. So let me just close it. I've saved what I've done so far. And here's the one that Jorge made yesterday. It's exactly the same design, but in the libraries that we have that have the models already mapped, the symbols are slightly different. There's no difference at all. I could have had made my design using those as well, but it's just I thought for viewing purposes, using the ones that we have in our library are a little bit more appealing. Therefore, as you can see, it's the same design. Jorge, I want to put 2 ammeters here, which is that's where the simulation is actually going to be measured from. So I'm going to go ahead and enable simulation. Transient. Go ahead and click on simulate. I'm going to turn off some of the signals because I only really want to be able to see the current flowing through the LEDs. So I'm going to go ahead and click on signals here, and I'll turn off the input and V1.
I hate that we default showing that current, that default power
That'll
curve.
change. That'll change.
I know it's going to change, but still,
So
in
just give it a
case
minute.
before anybody else mentions it.
So I'm going to zoom in on this a little bit because it's kind of big. So let's just make it a little easier for us to see what I'm.
Wrong way.
Yeah, there we
There you go.
I got it. Okay, so let's just put this side by side with the schematic. I should move that schematic a little bit more. Let me move it. Let me move the schematic off to the side a little bit more. That way they could see the plot. That way the plot makes sense. So as you can see, when it's on the screen where I have it right now, you could look at the values right here on the ammeters. That way you could see at which portion it actually this LED is on or off as well. As you can see it. So when you see the minus 15th power amp, that means it's off. And when you see it on, it gives you 0.24, almost 0.25, 0.025 amps. Okay. And this is essence ends the webinar, everything that we actually wanted to cover today. Appreciate everybody attending. So let's take care of some questions and see what happens.
Take care of YouTube. I'm still dealing with the Q&A over here.
So I see one question is, these are about the caps. At this time, we don't really add the voltage caps. We don't have a, but you could add that attribute just to let you know. The ones that I'm using here, I think are 24 volt capacity. That's what it was when I was doing my research on this. But you would have to add an attribute to give the voltage rating. By default, no Fox. Questions from Fox. I think I've started the line. Okay, so yeah, usually you want to end at a net. You don't want to start at a net, but it's possible to start at a net. And if the dot did not appear, just go ahead and use the junction command and place your dot there. That's not that big of a deal. Just click on junction and put it there. And when it does, it's going to give you a prompt asking you, do you want these two nets to connect? And then you say yes. Okay.
By the way, in this simulation, it's very important, Ed, if you can show them on the capacitor, there's an attribute there called spice init condition. The initial condition of that capacitor is very important. It needs to be at some voltage initially, otherwise the simulator chokes on it. So if you can show them how to define attributes, Ed, that'll be helpful because I know Mark is asking about that as well.
Okay, very well. So the define attributes, basically what you do is that you go to the, let me go here. Let me close this. Oh, just put it on this other screen. So right here, you see the attribute dialog box right here. I don't know if you can see it. It's on my left-hand side. It looks like a price tag. You click on that, and then you click on the component. As you could see, this component already has the attributes because of it's already a matte spice model. And you could click here on new, and then you could put here, I don't know, let's say voltage, and then you could provide it a value. And there it is. And now if I go to the properties of this capacitor, you'll see right here, there's a voltage. Now, I also want to let you know, the interesting part of this is that those attributes that we define either in the library or directly on the schematic actually make it to the list, to the bill of material, which it makes it very useful. It will actually get added to the bill of material for you.
Yeah, and just to add, the attributes command lets you control whether the attribute is visible or not. because there's some attributes that are internal. For example, you don't care to see the spice prefix. So that one is invisible by default. But if you wanted to see the voltage, then you would just edit that attribute so it appears on the schematic.
Hey, Colton. Thanks for being here. Appreciate it. Colton, he's been using Eagle for a while, but he said, you know what? Let me get a refresher and joined us. That's pretty cool. Thanks a lot. Appreciate that, Colton. Good stuff. Okay, so let me see if I have any other questions here. You know what? I'll do. Somebody's asking about differential lines and length matching. I'll try to do a little bit at the end on Thursday because it doesn't really apply here. Okay, it doesn't apply to the schematic. I'm sorry, what? Oh, there's more questions here.
So,
Okay.
Ed, I don't know if can you go into the attributes thing again if you have a chance?
Absolutely. To the attribute command?
Mm-hmm.
Sure, of course.
So go into attributes, pick that capacitor again.
Mm-hmm.
Pick the spice init condition there. Double click it. And just this is from Mark since he wants to know how to make it visible. See that display property? Right now it says both. So that means both the name of the attribute and its value are shown. You can also specify if you only want to show one or the other or show neither. Does that help? Yes, he's good.
There's some questions here about the outer route. The outer route system and the board can work in straight lines. Of course, it can, but it's just a preference. It will angle depending on whatever it needs to do to reach the end point. So I can't force it. If you need to force straight lines, then you're better off actually doing manual routing, to be honest with you. If that's what you need to force. But
Yeah.
the outer router, or we actually have another tool, and I don't know if you tried it. It's called Quick Route, and actually does a really good job at going straight, to be honest with you. But those are topics I'll cover on Thursday with Jorge. I don't see a convenient place I can put in. Can you increase the size of the frame, and how can I add sections to it, such as I can place power in one section, motor controllers in another? Okay, that's kind of a tricky question because this frame that I'm using, I'm actually using one from a library. So you would actually have to edit it from a library. Another way you could go about it is this way. Instead of adding the frame from a component, let me just delete this frame that I have here. I could delete this frame, all the information in it, and I could go over to the tools menu. I'm sorry, the edit menu, and we have the frame command here. Oh, draw. It's under draw. And it's frame right here, frame. And we have the different options, how I want my frame how I want the coordinates being displayed. And I gotta make sure that I'm on the symbol layer. So you would delete the frame and then just draw it in again. If the component if the labels of your nets are done appropriately, it will automatically update the coordinates for each one of them if you're using labels at all. So let's say, for example, where it says here labels, I could label this here, that label that you see here. It's called $1. Let me zoom in on this. If I click on here and I go to the properties, and I tell it, on the label, if I enable transfer reference right here, what that does is that it will now kind of generate or make it look like a port symbol. And what that does is that if this signal actually was moving into different schematic sheets, it would tell me the location and which sheet it's at. It lets me know the transfer of that signal throughout the different schematic sheets. That's if you wanted to do it that way as well. In addition to this, let me see, what was the other part of the question? Okay, so defining multiple sections on the schematic, actually, that's very commonly done using yes, the line command on one of the reference layers. So let's say I use the line command here, and I'll use a different layer, let's say like the information layer here, and I will change, instead of being continuous, I will actually change it to, let's say, for example, short dashes. And this is the way I've seen many people actually do it, and it works really well. And then they title it. That's one way you could do it. Okay. Another way is actually using the latest feature that we have called persistent groups. What you could do is that you could select all the assets that are going to be part of your persistent group. Let's say I have the group command active. I click and hold. And I select this group. I right click and I select new group and I give it a name. Let's say we call this test. As you could see, this is the group of all these components. And actually, if I try to move my group, it will move all the assets that belong to that group. And within a group, I could actually have subgroups. So if I go ahead and I define within a persistent within a persistent group, I could go ahead and select this one, and I'll say new group as well. I'll call this test one. Yeah, test one. So here's test one, which is it's not part of the bigger group. It's an independent group from the other one, but I can make it part of the other group if you needed to. So if I click here and I select all these assets here, and I right click and I say add to, let's say, for example, I selected these components. Sorry about that. I say add to group. These don't belong to a group, but I want to add it to an existing group. I could say I want to add this to test. So you'll see now it adds. So you could have groups within groups. You could have selected assets defined within a persistent group as you wanted to. So yeah, it's actually a very, very handy feature. The developer that worked on it did a really, really good job at this. It was excellent, and lets you, work on this as well. Also, we have the new filter, and the nice thing of the filter and is, let's say, for example, you have a little bit more complex design, and you want to find those components that do not have a spice model attached to them yet. So here I have it under object type category, and now select here where it says require spice model here. Okay, so it will show me components that require a spice model. Yeah. So all these components here that we have a list, it's just letting me know they do require a spice model. So the ones that would not show up on a list would not be, would not have a spice model to it. And the same thing you could do it with other, and then you could keep on adding to this requirement and adding to this filter as well. And this was just recently added on Eagle 9.51. We have tutorials based around this as well. Well, I'm almost at the top of the hour. Jorge, anything else I should be covering?
You have any Q&As left? there?
I see
No,
10.
on YouTube. On YouTube,
No.
yeah. If
Let me
not,
see
then
if
you got to jump in and help me on the Q&A here.
Okay, very well. So no, on YouTube, I think our friends are pretty doing pretty well. So thank you, Fox. Appreciate that. Let
We
me
have,
just go ahead and take care of some questions over. We're having a local chat here going on.
yeah, we have, can you export a group of components to a new schematic? And that's Daniel's question. If you want to answer it live, you want to answer that one live?
I think I can. I mean,
All right. So
the way you mean to a different design?
yeah, he wants to take a group of components and put them in a new schematic.
So basically, it's group copy paste in a sense. It's one way of doing it.
One way, you have design blocks also.
Or you could just go ahead and define what's called a design block. Let's say, for example, I could click. Let's say I'll just use this group here as my. I'll select all these assets here. These are all selected, and I could click here where it says File, and I could click here Save Selection as a design block. As you can see here. And I think that opened up a screen somewhere else. Give me a second. I got too many screens open up.
Bring it in.
I got too many screens going on. Oh, okay. So now I'll go ahead and define the group. File, save selection. And then it says control right click. It's not behaving as the way I expected it to behave, Jorge. So I define, I select all my assets that I wish to use in my group.
Mm-hmm.
Let me go here.
Remember, it can't handle persistent groups.
So do I need to delete them?
Yeah, you have to clear the persistent groups because right now it can't deal with them.
That's why. Then that's not working. Get rid of my persistent groups. Oops.
Oh, you killing stuff, man.
Yeah.
Se te fue la mano. Remember, you want to clear the group, not delete it, because if you delete it, you'll trash everything that's in it.
I want to ungroup. So I right click it, select
Ungroup.
ungroup.
There you go.
Right click it, ungroup. Okay, there we go. So now I could go ahead and select the assets I want to use. Click on File, Save Selection as Design Block.
Check your little dialog and with this somewhere.
It says Control right click to finish selection.
Yeah, control right click in. Remember, it's command. You're on a Mac. Hate the Mac. No offense to you Mac users, but I don't dig.
I think maybe we need, forget it. So you have the choice of doing a selection of assets or the entire schematic. Under the File pull-down menu, I could save here. It would save the entire schematic as a design block, or I could just save a selection. So to create a selection, I click and drag the area that I wish to use, the sub-circuit I wish to use in other designs, most probably. I click there. Okay. And then I go to the File, Save Selection as Design Block. And there it is. That's my selection that I created. I could give it a name. Save as. It's going to automatically go to my design block folder under documents. As you can see there, it's going to automatically go there. And let's go ahead and let's say I created a brand new sheet, or I switched to sheet number 2. And I go and I select design blocks here. These are examples. These are the ones that I've created. And here's the one that we just created a minute ago. I click OK, and I can go ahead and place it there. Oh, apparently I rotated it when I brought it in. My mistake.
Ooh. It's off in space.
Yeah, I wonder why is it doing that. It's behaving kind of erratic there when I try to paste it.
I think your thing is off in space, isn't it, Ed?
No, on a blank. You see my origin right down the bottom left?
Yeah. Mm-hmm.
So I click on design block.
Mm-hmm.
There
Ah,
it
but you
is.
got the whole schematic. I thought you were just gonna get the selection. And your schematic is kind of messed up there too.
So yeah, it kind of things got moved around a little bit. I'll just do this selection here. It makes it a little easier. Oh, right click there. Save as. Call it flasher. Let me go to sheet number 2.
There you go.
It's kind of strange though, Jorge. It's bringing it in rotated every time.
Happens to me sometimes. Check your press right click. You get it to rotate.
There it is. Yep.
Yeah. It just
One more time. There you go. One
it
more time.
just lagged a little bit.
So it's just letting me know that there's the block that I'm bringing in has net names of that already exists on the schematic. So it's letting me know what's their old name, and it's actually going to rename them. Okay. So we have some components here, the LEDs. It's going to rename on my the block that I'm bringing in. They're called LED 1, LED 2 is going to change them to 3 and 4. Okay, for this one, my signals are going to up to 3 and 4. Are going to go 5 and 7, and so forth. So it's just letting you know what's going on. That's what this little report is doing right here. Okay. If I wanted to actually keep the same name, I would double click it and actually put the name right there. If I wanted to actually use that name in $3. So let's try that in $. See? So if I wanted to I actually have to go in there and do a manual. And the reason for this is for protection purposes. You don't want to, by mistake, use um, use a block, a design block that will actually create shorts on your design. And that's why this list comes up. And see, it's not an automatically pay. That's why it doesn't automatically place it. It will actually give you a report, and you have the choice at that point on if you want to actually rename them, and you have to rename them manually. Okay. I'll click OK. And now it's placed appropriately. Any other questions I could help you out with?
Check out Craig Field's question.
Okay, on Q&A?
Yeah.
I see you typing along quite a bit there, Jorge. Apparently you
Yeah, I've
been
been
a little busy today.
Yeah, a little bit.
I like it. Kind of glad I didn't do it by myself.
Yeah.
You have 30 answer Q&A questions?
Yeah, I think that's the record, isn't it?
Hey, that's your beast.
All right, so you showed how to export. If Daniel, if you're happy, let us know in the chat.
Which is the one I can't find the one you're telling
In
me
the
about.
Q&A, it's the from the top 1, 2, 3. It's fourth question from the top.
What's his name?
Craig Fields.
Oh,
How to edit net, delete sections.
okay. Hey, Craig, how are you today? I hope everything is going well. So I'm going to go to my original design. I'm not going to save this one. I'm going to go to my original design. Save no. Let's go to our original design. What are you working with? Okay, so how to edit net. So to edit a net, basically, it all depends what you're trying to do. I'm not really sure exactly what you're trying to, how to edit the net. But to delete sections, what you're going to be doing is that you're going to actually, it's kind of like use a slice command if you wanted to, is the best way, and it actually breaks it, as you could see there. The slice command actually breaks almost anything that it intersects. And that's one way of breaking it. Now, we do the show command here. You notice that section is now $7. Now this section is $8. I'm looking right here in the bottom.
You got to zoom in because that little gap is really small.
Okay.
There you go.
Okay, so just to let you know, so I'll use the slice command one more time. That way you can see how it works. As you could see. And then in every section that it's slicing, actually it adopts a different name. Okay, so each one of these now have a different name, just to let you know. So that's one way you could, if you wanted to split a line, that's one way you could go about it. Another option that you have is we have the command called right here called split. The split command, basically what it does is that it actually generates an elbow for whatever line you connect to. So that's what the split command does. Okay. That's one way you could go about it. That way you could edit it. Now you could move any of the junction points of this net independently. As you could see, I can move it independently. Okay. So I hope I took care of Craig's question. Answer live.
Okay.
I didn't.
Check out Varga if you can help out Varga.
Hey Vargas, he has some pictures there. I'll try to see if I can take a quick look. We're kind of live, so I don't know. Oh, it looks like a 7-segment LED display, but made with, what are these, pixie lights? Whatever it is, it's really cool looking.
Yeah, okay. Just be careful not to give away the family jewels. I don't know.
No. I'm not, that's pretty cool. Anyway.
He's having issues with when he takes it into Fusion 360. He says it looks weird. Like the components look okay, but the board looks weird. But I wasn't 100% sure what the issue was with the board.
Well, to be honest with you, on the link that he's giving us, I see no silk screen at all. So I'm going to go ahead and imagine that this is his Fusion render.
That's what I was thinking too.
So it seems. Are you sure that you're using the appropriate silk screen layers, Varga? Make sure that you're using the T name, the T value layer, and just make sure that you're using the appropriate layers. Okay. I'm just wondering that if you're just placing your silk screen on the layer that doesn't belong. So if you use like a measurement layer or reference layer, that's not gonna help. So you got to use like the T-place layer for it. Okay. I hope that works. I don't know. That's a tough one. Remember, you could always reach us. Let me put on the chat our email address. I don't know if I should turn off the YouTube feed.
Is anybody still asking anything on YouTube?
I'll be really honest with you. No, nobody's asking, but the group is getting bigger. So apparently, whatever we're doing fine.
Rock on.
Yeah, apparently we're doing good. How to use the bus command example with LCD on MCUs.
It works the same way. Go ahead and show them a bus example, like with a breakout and stuff, because that's where it's really impressive when you break something out and then you form a bus out of it. And
So let's say, for example, let me duplicate this and please ignore. We know this is totally wrong, but this is just what I have in hand right now. That way, I can show you. Okay, so we'll use the net command, and we'll use this tool right here. It's called pin breakout right here, and we'll just custom label it. Let's say, for example, net one. I'll say auto increment, and I'll use a minimum wire width.
oh, but you gotta specify.
Oops, I'll use 5 grid points. So I just click here, boom.
Missed it.
I missed it, missed the connecting point. There, and there, and there, and there. That's one way you could do a breakout. It's really easy, simple to use. Another way is right-clicking the component itself. And you could say the option breakout, which is breakout pins right here. You could do selected pins, or you could do all the pins. I'm going to go ahead and tell it just use the name of the default name or the name of the pins. I'm going to use default pins as I have here. As you can see, it does the breakout. Now I could go ahead and I could select all those nets that I have there and right click and say make a bus right there. Make a bus. It's going to take all the members of the net that I have selected. So let me see.
Remember, when you make a bus, you have to draw it out.
Make a bus. Okay.
So just draw it.
Yeah, there you go.
And just double click at the end when you're done.
Okay, there it is. And there's all the members, which matches the names of these nets we have here. As you can see, that's the member of that bus. And I could give it an alias name. I'll just call it like 555, just because that's the component that we're using. That's the alias. Now, if I use a net command and I click on this bus, now I could select from any of these nets that I had. So it's really useful, as you can see. And $8, 11, 12, or 13 are right there. So if I actually had this bus on a different sheet, it's really easy for you to transfer it within the same schematic from one area to another area, or from sheet to sheet. Actually, I could actually even break out all the nets, as you can see here, and I could just break them all out as well if I wanted to connect another component as well. Okay, so you think that answer his bus questions?
I think so.
Okay, excellent. Bus demo, beautiful. He liked it.
Yeah, he did.
He liked it. He did like the buses.
Okay. Yeah, he did.
Hey, Richard. Hey, Richard, join us.
Oh, Richard, jump in?
Yeah, he's in here.
Why is he all quiet?
But he's on YouTube.
Oh, he's on YouTube. Ah, that's how he avoids getting hammered by all the questions.
Next time you got to be with us in here, Richard.
All right, I think we got everything. If we're missing anything, let's go ahead and put in any last questions. Mark, we do show how to do libraries and components, but that's a different webinar. We actually typically do a webinar just dedicated to that on its own, because it's a big subject.
Yeah, I actually split it in 2 parts usually. So I split it by like the old way of doing it from scratch,
Yeah, and then we do all
and then
the.
the other webinar is like using all the new shortcuts that we have to create parts really easy.
Do you know when the next library webinar is? Do you remember
No,
off
I
the top
don't
of your
know.
head?
No, I don't know. Sorry. Shoot me an email to our support.eagle@autodesk.com. I'll let you know. Or just go to our webpage. Let me see if it's there. Give me a second.
Check if in the control panel it shows up, or no, the control panel only has like
No.
the next 3 weeks or something.
Yeah, exactly. Let me see if I can find it really quick. Okay. Let me go here to webinars and events. So
Thermal.
we have the mapping one. We're doing mapping simulation.
The mapping one doubled up for some reason. Don't know what's up with that.
I think one is in English, one is in German. Maybe. No.
They both show English.
Yeah, I don't know why they show up. Okay.
Okay, so we don't have a library one coming up soon. We need
Okay,
to.
so I'll do one in early November then. Okay. I'll do one in early November. I'll schedule one for early November. Okay.
I think.
I'll
I think we're
so
good.
yeah, really soon just come back to this page and you're gonna see a link to the registration page for creating parts. So I'll dedicate November to creating parts. That's good, Jorge.
Yeah, I think that's
Yeah,
good.
we'll make some parts over there on November. Okay, everybody. I think we've covered everybody.
Everybody happy? Please say
I think
everybody's happy.
hey, Fox has a smiley face, so he's good. So as long
Eh.
as Fox is good, all is good, all is well. I just find it funny that the group keeps on growing. The group keeps on growing. Yeah, it's pretty neat.
All right.
Well, let me put over here my the email address in case our YouTube friends want to get in contact with us. So I'll put so. Oh, you did?
Yeah, Lourdes took care of it.
Oh, okay.
Alrighty.
Everybody, it's been a real pleasure to be here with you. And Jorge, I can't thank you enough. I don't think I would have been able to pull this off on my own. In the last minute, Jorge was like, "Yeah, you know what? I'll join you." And like, oh my god, I'm really happy he did. We have I would be here for like 2 days answering questions. Everybody, it's been a pleasure. Have a great day. Thank you for being here, and I see you on Thursday. And we'll take care. We'll try our best to have some really nice examples set up for differential pair and meandering as well. Thank you, Richard. Thank you for your kind words. Appreciate it. Thank you, Josh. John, always a pleasure to hear from you. See you
John,
on the next one.
just before he goes, because he wanted to ask what changes are 9.5.1, basically bug fixes. This
Mm-hmm.
this one's just a bug fix release. Oh, no, the managed folder thing came out in 9.5, not in
No, I think
9.5.
she's talking about the reference library update,
Oh,
but
that one,
that's
yeah.
I guess so. Yeah, yeah.
Yeah, we should mention that.
So
That
the we have a library called Reference Packages 3D that has the footprints mapped with 3D models, and the librarian team actually added like 500 new assets to that library. Pretty impressive.
yeah, check it out. So if you're building components and you want to just, get the 3D model for free, you can grab it from there and it'll come with it. So
And
that's pretty cool.
they're all IPC based compliant components, so they're pretty decent to use. So it's called uh, Reference Packages hyphen 3D.
Yeah.
This is the name of that library. Okay.
Yeah, so just update if you go into the available tab, you'll see it there. And I think new versions of Eagle ship with it as part of the
Mm-hmm.
managed bundle.
Well, yeah, it's in the managed library. I think it automatically installs you, correct, or updates. If
Right.
you already
I
have
think you
Eagle
have to
installed,
update it.
you gotta go out manually and update it. Okay, excellent. Now these libraries are only contain footprints and 3D models. So what you would usually do is that you would copy them into your own library. That way you could take advantage of the created footprint and the 3D model. Okay, and I have plenty of tutorials of how I've done that on the YouTube channel. So I teach you how to copy. Uh, Either you could export from the control panel into a library or from a design to a library as well. So
Yeah. Actually, I was thinking we have a relatively recent library webinar on our YouTube, right? So Mark could check that out.
yes,
If he's in a hurry, he could check that out.
hmm
And it's a relatively recent one.
The library webinars are usually between 30 to 45 minutes. They're not short because we kind of are kind of detailed on those. So just be patient, and you could scroll forward until you get to the part that you'll like to. And okay, I think we're done. I don't see any other questions here. Let's see.
Nothing on YouTube, right? We're good there.
Oh, okay. Oh, Richard say reference package 3D is awesome.
That's right.
And then Fox says PCBs equals paying the bills. Excellent. Thank you, everybody. We had a really good time. Um, I hope you had such a good time as we did. And we'll see you next Thursday. We'll see you in 2 days. Everybody have a great day.
Everyone,
You bet. Thank you.
Mark, just ping us through the email and I'll see if I can find that video for you.
Absolutely.